I'd still like to talk about one-to-one and inverse functions. In particular, I want to give you 3 properties of inverse functions that you need to know. Okay? So let's write these down. Let's say we are given a function f of x that's one-to-one. And we have an inverse function, f inverse. Then the following must be true. Property 1. If f has domain A in range B, then the inverse function will have domain B in range A. Okay? The domain and range simply flip-flop. The second property that we need to know is that the graphs of f inverse are reflections about the line y equals x. We saw an example in the last lesson where we graphed something like this. That was f. And we saw that the graph of f inverse was simply a reflection about the line y equals x. The last property, which we haven't talked about yet, is the following. It has to do with the composition of the two. F composed of f inverse of x is equal to x for all x in the domain of f inverse. Also, f inverse composed of f of x is equal to x for all x in the domain of f. So write that down. You might want to put this on pause. We'll investigate this a little bit. Okay. Hopefully you wrote that property down. Let's take a look at a couple functions here. It says f of x equals square root of x. Certainly that's a one-to-one function, so it has an inverse. The inverse function is x squared. But notice we had to restrict our domain because x squared is both sides of this parabola. Okay? But if we restrict the domain to only positive values, that would be the inverse function of square root of x. Okay? So there is a function and its inverse. Now you want to find the following. F composed of f inverse of 3. Remember our property here. F composed of f inverse of x is equal to x for every x in the domain of f inverse. So take a look here. According to our property, this must equal 3. Let's check it out. First of all, remember to do compositions, you do the inside first. F inverse of 3. Well, here's f inverse of x. F inverse of 3 must be 3 squared, which is 9. F of 9 means you plug a 9 into the f function. The square root of 9 is 3. Okay? What about f inverse composed of f of 1? Well, that's no problem. That's got to be 1. Right? Because f of 1, if you plug a 1 into the function, is 1. F inverse of 1 is 1 squared, which is also 1. Let's try this one. F inverse composed of f of x. Let's see what we get there. F inverse composed of f of x is equal to f inverse. Well, f of x is right here. Square root of x. That means we plug the square root of x into our inverse function. Square root of x squared is x. And that's a nice property. If ever we have inverse functions and we compose the two functions, you're always going to get x. Let's look at this here. It says f composed of f inverse of negative 3 is not negative 3, since negative 3 is not in the domain. Remember our property. This is the subtlety here. F composed of f inverse of x is equal to x for all x that's in the domain of our function. If this little x is not in the domain, we cannot apply this rule. And notice, f inverse of negative 3, if we look at our graph, negative 3 is not in the domain of our inverse function, right? There's our inverse function. Negative 3 is not in the domain. So we cannot say this. F composed of f inverse of minus 3 does not equal negative 3. So that's an important rule. You might want to review that a couple times. Okay? So, again, let's review the three properties that you need to know. The first property is that if we have inverse functions, the domain and range simply interchange. The graphs are reflections about the line y equals x. And the third one, if we compose the two functions, we're always going to get x, provided that x is in the domain of the inside function.